Okay, so today we're going to look at simplifying radicals. The radical is this symbol here. Okay, and you definitely want your calculator available because we'll be using that. Okay, a square root symbol is sometimes called a radical. The number in the radical is called the radicand. So say you took the square root of 7. 7 is the number 7 is the number in the radical, and it's called the radicand. And then the whole thing is the radical. When you have multiplication with radicals, as long as you have the same root, you're allowed to do that. So for number 1, 2 times 3 is 6. That's pretty straightforward. Here, since they're both radicals, you are allowed to just keep the radical symbol and then multiply the radicand. So you're just going to do 2 times 3 in the radical, and that'll give you the square root of 6. Now, the square root of 6 is not a perfect square, and we'll review perfect squares in a couple minutes. For number 3, 4, and 5, you do the same thing. So go ahead and try 3, 4, and 5. You should be getting the square root of 15 for number 3, the square root of 70 for number 4, and then the square root of 25. One of these simplifies. Which one? You can tell me. Go ahead. Yep, so square root of 25 is 5, and we will review all the perfect squares. So 25 is a perfect square, so it's a number times itself. All right, I'm going to highlight when a radical is fully simplified, it will not, A, contain any perfect square factors. B, it will not have a fraction under the radical. Or C, a radical in the denominator. So those are the things that we're looking for. So you're looking for fractions. And again, just a reminder, I'm on page 9. This is page 9 of our packet. We're on page 9 of the packet, and we're going to hop over to a different page in a little bit. So what is a perfect square? A perfect square is a number times itself. The number times itself. So 1 times 1 is 1. 2 times 2 is 4. There's an infinite number of perfect squares. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is, oops, I wrote the wrong thing. At least I caught it. All right, 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And then 15 times 15 is 225. I'm going to skip 16 times 16, 17 times 17, and so on. But the next one that's actually pretty nice is 20 times 20. 20 times 20, 2 times 2 is 4, and then 10 times 10 is 100. So 20 times 20 is 400. And then, bless you, you could do the same thing for the next one. So 30 times 30 is 900. Yeah, and then 40 times 40 is 1600, and so on. So sometimes that's just nice. You can kind of look at these and just have the extra zeros. Okay, so when you simplify, you're looking for the largest perfect square factor that is a factor of the radicand, the number under the radical. We want to write the factor as 2 separate square roots. And then we want to simplify the perfect square to an integer and rewrite the non-perfect square under the radical. So simplify to an exact answer. So let's just start over here with that square root of 8. So I want to look for factors of 8. And there's a few ways that you can do these. Some students remember this and can do this very quickly. Others really struggle. First of all, is 8 on our list? And it's not. Okay, if it was the square root of 9, then it'd be a perfect square. Square root of 9 is 3, then you're done. But 8 is not on our list, so it's not a perfect square. 8 would be here on the list, so the only factors below it are 4 and 1. I'm never concerned with 1 because all numbers have a factor of 1. Is 4 a factor of 8? It is. Okay, so there is a, you always want to find the largest perfect square factor of the number. So this is 4. 4 times 2 is 8. So this is the product property where you take your radical and you split it into two radicals. So the square root of 4 times the square root of 2 is the square root of 8. So I split it into two separate square roots because one of them was a perfect square. If one of them is not a perfect square, that's unnecessary. Then the square root of 4 is 2, so your final answer is going to be 2 root 2. On your calculator, you can do this a few ways. So I can do the radical symbol. On this particular calculator, the radical symbol is above the x squared. So I can do second square root 8. And now this particular calculator has math print on it, and math print will do this for you. If you go to the mode, which is to the right of the second button, you can see that I'm in the math print menu. Many calculators have that menu, but not all. And then I'm going to do quit. And then I can use this key here, which is the change form key, and it'll give me the decimal approximation. Now, it didn't ask me for a decimal. It asked for the exact answer. So the exact answer is the 2 root 2. All right, another way you can get this is by doing prime factorization. So if you look at the 8, you might have said, okay, well, 2 times 4 is 8. And I want all the prime factors of all of the factors. So 2 is prime, 4 is a composite number. So I want to break down that 4 to 2 and 2. And then I like to bring all those numbers to one row. You don't need to do this right now, but it's a nice strategy for maybe a harder one. And then you're looking for a pair. So I have a pair of 2s. And if I multiply those together, I would have gotten here. So that's another strategy. Okay, so let's do some here at the bottom. All right, so for some reason we're starting in number 6. Oh, because we had 1 through 5 at the top. All right, so for number 6, simplify to an exact answer. The square root of 20. So you might say, all right, well, 20 is 2 times 10. So let me show you the prime factorization way. So 2 times 10, 2 is prime, but 10 is not. So 10 is 2 times 5. So I'm going to bring, and now I have 3 prime factors. I have a pair of 2s that's being repeated. So I'm going to put those together. So I like to put the perfect square first. So I have the square root of 4 times the square root of 5. The square root of 4 is 2. So your answer would be 2 root 5. And then you can always check, because is 20 the same thing as 4 times 5? And it is. That's equivalent. And then I just took the perfect square and I made that a 2. All right, so that was using prime factorization. Let's do number 7 a different way. So I have 27 here. So I'm going to go up to my list. So that means 27 would be here. Are any of these numbers, 4, 9, 16, and 25, a factor of 27? 9 is. So you would have 9 times 3 to get 27. So you're looking for the largest perfect square factor. And then the square root of 9 is 3. And then you're good to go. So, and it doesn't matter to me which method you use, either way is fine. Some students really like to do the prime factorization because it's a procedure that you can do every time. All right, so 27, 20, the square root of 20, square root of 27, square root of 28, none of those numbers, the 20, 27, or 28 are on the list. Neither is the 30. So let's just take a moment and try 8 and 9. All right, so you can try 8, 9, and 10 on your own. To use your calculator, you're going to do second x squared, or a caret. On some of them, they have a caret. And then the radical symbol should come up, and then you type in the number, and then hit enter. In general, some students can do these really quickly, and then for others, they take a while. So it just kind of depends. Some people can just figure this out quickly, and other people, it's a little bit more of a struggle. I'll give you 30 more seconds. I meant to do that. All right, so let me talk you through these. So for number 8, I did 2 times 14, which is maybe not what you would have done. Maybe you went right to 4 times 7 or 7 times 4. But I knew that 14 could be broken down further. So then I broke down 14 into 2 times 7, and I had a pair of 2's. So 2 times 2 is 4, and then the leftover 7 goes here. Square root of 4 is 2, and you have 2 root 7. In number 9, the factors of 30 are 6 and 5. And 6 breaks down to 2 and 3. There are no common factors. So this one is just simplified. Okay, and then number 10 is from our list. It is a perfect square, so it's just 11. Okay, number 11 is one that's a very popular question. So if you look at the 50, let's try the method where we go up here to our list. Do you see a factor of 50 that's on this list? What is it? 25. 25 is a factor of 50. So you can make this 25 times what is 50? Well, 25 times 2 is 50. So you can do 20, square root of 25 times the square root of 2. 25 times 2 is 50, and then the square root of 25 is 5. So it's 5 root 2. That is the easiest way to do this question. However, if that's a struggle for you, you can always take the 50 and then break it down. Okay, so I can do 5 times 10. 5 is a prime number, so you're all set with that. And then this is 2 times 5. I like to bring them all on one level, all on the same line, because it's easy to lose a factor. And then here's your pair to get the 25. And then whatever was not circled would multiply together and stay in the radical. So even here, 2, 3, and 5, you can multiply those together to get the 30, and it just stays in the radical. Okay, number 12, I have the square root of 72. Now this one's a little tricky because 72 could be broken down a bunch of ways. So maybe you look at this and say, all right, well, this is the square root of 4 times the square root of 18. Okay, and if you're not sure, you can do 4 times 18, and you get 72. All right, well, the square root of 4 is 2. So it would appear that you're done. Now I have 2 times the square root of 18. The issue is that 18 can be broken down further. 18 has a factor of 9. So you want to take the 18 and do this whole process again. 9 times 2 is 18. So I'm actually taking the long way, but many students will take the long way on a question. So they'll get to a place like this and think that they're done, and then they missed a perfect square factor. It happens all the time. The square root of 9 is 3, and then I have the square root of 2 left. So then your final answer is 6 root 2. And that's your final answer because the 72 could have been written as 36, square root of 36 times the square root of 2. And that would have been the most direct way to get to my answer. So if you missed that 36 was the largest perfect square, maybe you did 9 and 8. So that's really popular where somebody says, okay, this is square root of 9 times the square root of 8, 3 root 8. Well, that's fine, but then you'd have to go back and do what we did over here and convert that to 2 root 2. And no matter what, you're going to get down to 6 root 2. So you can take a different path to get to the same answer. Okay, are there any questions before I go on? All right, we're all going to flip to way back towards the middle back of the packet. And let's go to page 30. So there are just a few things that I want to show you here from the back of the packet. So some of these are kind of complicated. Number 1 is a really complicated question. I would not multiply these 2 radicands together because that just kind of blows up on you. So what I would do is I would break down the numbers. 15 is 3 times 5. 75 is 25 times 3. And then 25 can be broken down again. So 25 is 5 times 5. So I got all these numbers. I've got the 3, the first 3, the first 5, 2 more 5s, and then another 3. So that's a lot of numbers. Got a lot of numbers here for this one. I'm showing you a little bit more than what you're going to need just so you have some good exposure. Okay? The 3s are a pair, and you have 1 pairs of 5. 1 pair of 5s. Okay, and you can multiply these all back together. So this is 3 times 5 times 5 times 3. And you could go right ahead and do that on your calculator. 3 times 5 times 5 times 3. And I'm getting 225. So the first number is 225. The second number is 5. And then do times 5. And if you notice, I get 1125. And if I do 15 times 75, I get 1125. So these are equivalent, so I'm good. And then you may or may not remember 225 from our list. So if you forget, you can always just take the square root of that. And if you did it right, you should be getting a perfect square. So the square root of 225 is 15. So your answer here for this one, and this was a harder one, is 15 root 5. Okay. Number 2, you have 8 times the square root of 5 squared. So that is 8 root 5 times 8 root 5. And you're going to multiply the numbers together and then the radicals together. So 8 times 8 is 64. Square root of 5 times the square root of 5 is the square root of 25. And then the square root of 25 is 5. So that is 64 times 5. And that comes out to 320. Another way you can do this is have that 2 be applied to each one. So you could have 8 squared and the square root of 5 squared. And this is really popular. You're going to see this a lot. So when you have a square root squared, it's like adding 1 and subtracting 1 at the same time. So this cancels. So that's why I'm just getting the 5 here. So I could have gone right to here if that made more sense to you. Okay, the next one is quite a bit easier. So I have 4 root 3 plus 6 root 3. So this is like 4x plus 6x. So if you did that out, you would get 10x. So it's really the same thing. You have 4 of root 3 and 6 of root 3. So the 4 and the 6 get put together. So you end up with 10 root 3. You can only do that if the radicals are the same. And in number 4, they are not the same. So you would need to rewrite this one to get the same radical. So we already did the square root of 8, and then I mentioned it again at a later time. So the square root of 8 is the square root of 4 times the square root of 2. We had done that a couple minutes ago. And then the square root of 4 is 2. So now 6 times 2 is 12, and you're going to get 12 root 2 minus, bless you, 1 root 2. So 12 root 2 minus 1 root 2 is 11 root 2. Okay. Let's save number 5. And number 6 is a little bit different because you have a radical in the denominator. So when you have a radical in the denominator, you need to get rid of it. So you're going to get rid of it by doing a process called rationalizing the denominator. So for easier questions like a number 9, where it's just like a simple number in the denominator, you can just multiply top and bottom by the square root of 2. When you have an expression, you're allowed to multiply by the equivalent of 1. So root 2 over root 2 divides to 1, so you're allowed to do that. In the numerator, they don't mix. You have a number and a radical, so it's just going to be 9 root 2. In the denominator, the square root of 2 times the square root of 2 is the square root of 4. And then the square root of 4 is the perfect square, so that's 2. So this would be 9 root 2 over 2. And you can just write it like that. All right, so we did a lot. I did a lot with just kind of basic things with the radicals. I know I kind of threw a lot at you, but I think the homework won't be too bad because some of them have a lot of pretty easy questions.